The last thing we want to cover today is we're going to move into the grazing land facility design, and this would be the actual engineering practices. So we're going to talk about the fence today, and then next session we'll work on the watering systems, pipelines, access roads, trails, and then at the end we'll go through a full-blown grazing plan and give you an example grazing plan of what we've done. So for designing fences for grazing systems, I want to get into the fact that probably the most effective and cost-effective fence we can use is an electric fence. The new technology for high tensile fencing really allows us to do the kind of things you want to do with intensive management. However, that does not mean that other fences can't be used, and they have their places, such as more permanent non-electric fences, such as woven wire, barbed wire. Those fences are needed in special places, especially we get into places where electricity doesn't flow because there's too much vegetation on the line or something, that it's in a very dense vegetated place where you wouldn't be able to keep the electric fences clear of vegetation. But what I want to just show here is compare the cost. And this cost is based on a 2008 figure, so costs have risen considerably since then, but I don't want you to be concerned about the actual total cost per foot for each fence as the relative cost for each fence. So if you look at construction of a woven wire fence based on 1,320 feet, because we require so many steel posts, every 15 feet, wood post, lots of staples, lots of corners. Basically, woven wire is not cheap. We have a total cost of $1.51. So relative to the other fences, the woven wire is going to be your most expensive fence. A 4-strand barbed wire is probably going to be next in line at $1.22. So if you just increase those prices by about, probably now we'd almost be looking close to an increase of 70% or more. We're looking at probably over $2 a foot for woven wire installed, and let's say close to $1.75 or more for barbed wire fence installed. If you get down to high tensile non-electric, based on 1,320 feet, a non-electric high tensile wire, you have to have more wires. Just so in this case, we have, looks like a 6 or 7 wire fence, because you have to put the wires closer together. They're more of a physical barrier than electrical barrier. So we have a price of $1.12 a foot. And as compared to the least cost fence, which is a 4-strand high tensile electrified wire at 70 cents per foot. So, increase those for today's prices. Again, you're talking about probably for the non-electric high tensile, close to $1.50, and for the electric high tensile, you're probably talking well over $1.30 for sure, or probably even closer to maybe even more, $1.50. I think is even some of our cost share rates are that high now. So the fence prices have increased dramatically, but the main point is that it's electric fence is at least half the cost of the woven wire fence. So that's why we encourage the high tensile electric. It allows you to do a lot more with interior fencing and temporary fencing and hooking power to it than anything. The thing is that if you've got an area where you're going to have a barbed wire or a non-electrified fence, and you want to carry electrification around the interior wires, you could always put an offset onto that. An offset is just a offset wire which is used with an insulator. Sometimes it's offset from the post a good 6 or 8 inches, and sometimes it's just you just have an insulator on the post on your barbed wire fence or your woven wire fence, and you can run your electricity around the farm that way, and then connect your interior wires to that. Polywire, of course, is real cheap. You know, it's not $3 a foot anymore, but it's probably closer to 5 or 10 cents a foot. It's really fairly cheap, but yet it's fairly low, has a fairly shorter life than say the 20 or 30-year high tensile wire fences do. The most important thing about electric fencing is the energizer. The energizer is the psychological barrier. If you don't have power to the fence, you just as well don't have a fence, because it's not a very good physical barrier at all. You've got to have a good perimeter fence to make sure the animals won't escape the farm. Interior fences can be a lot less durable and a lot fewer wires. So for perimeter fences, usually we say for high tensile electric, we'd like to see a minimum of 3 to 4 wires, 3 for probably dairy cattle, 4 for beef. Usually your fence laws will state that in your fencing laws. Wisconsin, our fence laws state for electric fence on the boundary, we have to have 4 strands, unless you get permission from the landowner next door, and then you can have a minimum of 2 strands. But for the most part, we're looking at 4 strands for a perimeter electric fence. Interior electric fence, usually 1 strand is adequate, unless you're dealing with very small livestock that you want to stay with the animals, then perhaps looking at might be 2 strand. Low impedance. Low impedance is what's on the market today. You don't really have much choice. Most everything is solid state electronics, low impedance. So if you don't, the old style, they would have a really problem with grounding out. And now, because with the low impedance, we have such high amounts of voltage, very short discharge times, it forces a shock through the vegetation, and basically it can do its job with pretty good high load on it of vegetation. They usually have a 100 microsecond or pulse rate of about 55 times per minute. So even though the voltage is very high, the animal's not going to die from it because it's very short. And once you get that very short pulsation, they usually have a reaction and they're out of it. The only time it would really threaten their life is if they got caught up in the fence. Yeah, very high voltage, very short pulse rate. It's not enough to physically do damage. What you want to be doing is you look at for the power involved in energizer. It's measured in joules. It's the amount of energy energizer is capable of producing. It's not, you don't measure voltage or amperage. It's a combination of volts and amperage together that gives you the joules, just like the watts when you're looking at your power that you purchase for your home. It's the amount of energy, the total output. What you want to do is you want to have enough charge on your fence. So when you test the charge, that you have anywhere from 5 to 10,000 volts. Even 5,000 in some cases for dairy cattle may be more than you really need. 3 might be more like it. But when you're getting into an animal with a pretty thick coat of fur, like sheep, probably 5,000 is what works for most situations. the most important thing to have with electric fence is a tester, some kind of a voltmeter that you can determine at any time what the voltage is on that fence. That will tell you how good it's going to do as a psychological barrier to those animals. You always want to wire the fence correctly so that power from the energizer to the fence is always the same size or larger wire as the fence wire. It's like if you had a feeder line for your water pipe coming in from the rural well or the rural city system or the city system, and it was a smaller pipe coming into your house and the pipes in your house, you wouldn't have very good water pressure. So it's the same thing. You want to have everything be the same size. Fencing circuits. Most electric fences run on an earth return system so that the power runs through the electric fence. When the animal touches the fence, the electrons run through the animal into the ground and back. But there's also a wire return system. For example, when you don't have good grounding of the ground, so for example, when your soils are too dry or you have frozen conditions in the winter, the animal might touch that fence, an earth return system, but there's no ground there because the electrons can't move on the dry ground or can't move through the frozen ground. So then you want to have what they call a hot and cold system or a plus and minus system. So here's an earth return, just positive wires, all the way through the wires that are just are hooked up are just a positive. The electrons go back through the ground through the animal. The wire return system doesn't rely upon the animal grounding it out. It relies upon the fence returning the electrons through. So if the animal has to touch both of the fences in order to get a shock, because if they just touch the positive fence, they're not going to have enough ground to take it down. But if they touch both of them, which they would if they were to get out, they would receive a shock because of the grounding of the second wire. Ground rods are connected to the wire at multiple locations along the fence, and that works best because then you have a fence grounding system as well as an energizer grounding system. So for the hot and cold system, that's the best way to run it, is to have separate ground rods. Just for the regular earth return, you just need ground rods for the energizer. The biggest problem we have with electric fencing systems is poor grounding. If you don't have the proper grounding, you don't have a good fence. And you need more than one ground rod. So for high tensile fencing, electric fencing, at least 3 ground rods are needed per energizer. And if you get more than that, you take the number of joules and you can determine the amount of ground rods you need by the number of joules in the fencer. A lightning diverter is very important. All it is some kind of a diverter between the energizer and the fence, that if power comes from the fence side, too much power from the lightning bolt, then it would not go back to the energizer. It would cut a circuit and break it off and ground it before it gets to the energizer. As far as number of ground rods, 3 feet of ground rod per joule of energy. So if you have a 10 joule fencer, you need 30 feet of ground rod. Ground rods come in 6 foot length, so you would need 5 ground rods. A minimum, though, for any electric fence is 3. I talked to you about a lightning arrestor system. This is very important to have on theirs. Everybody would have one. You don't want to ruin a $500, $600 energizer because of lightning. Obviously, it's installed between the energizer and the fence. It's common sense. There's a lot of different tools for doing fencing. I'll talk just about a few of them. Basically, for the wire itself, you'd like to see 12.5 gauge or larger, high tensile with a tensile strength of 140. You need the class 3 galvanized. Class 3 galvanized improves the conductivity of it and also improves the length of the years of life of the fence. So when you look at a spec sheet for the fence, you want to make sure you get class 3 galvanized. Braces are most of the braces that we use are floating braces because you only use 2 posts instead of 3. An H brace considers 3. They work very well. This angle brace or floating brace is much longer than this. So what happens is when the pull is coming towards us, this pulls this down into a block, and it has a very strong, it can take a very strong force, just as strong as the H brace, but less money because only 2 posts. Here's another example. You've got wires along here. Be careful, they can short out, so make sure you have some kind of insulator to protect the wire from the post. You don't want to go more than halfway up the post with your brace post, so to give it more strength. The direction of the pull, you want to make sure that you've got a wire below. Sometimes you can use staples here, and you could use the staples as protectives of the wood. So by having a staple in one direction where the wire goes on top of the staple, and then a staple on top of that, so that the fence wire won't go into the wood, works really well from digging into the post. 2/3 exposed piece height maximum. You want one half of the post height minimum for posting the ground. So if you need basically if you need 4 feet in the ground, you need 3 foot in. So basically you need 7 foot post. Here's basically just a typical single post corner with angle brace assembly. You've got your direction of pulls, 6 foot diameter wood minimum for a wood post in the middle is what we can use. That works pretty well, or a steel pipe would work as well. Here's an H brace. It is just as strong as a floating brace. Basically, an H brace, you have an angle wire depending on the direction, on the direction of pull. These are all just different kinds of things. One thing I will warn you is that these are the best way to go for insulators, not the insulators that go around the wire, because those can break down in the sunlight. So we usually recommend these porcelain insulators. And I know in Illinois, these in the NRCS standard, these insulators are not allowed. This is just what you would use to tighten the wire. And this is the direction of pull, so that as you have your diagonal in your H brace, would be towards the uphill side would be towards the direction of the pull. And if you have, these are pull post assemblies are used on mostly barbed wire and barbed wire fences and woven wire, where you would need one of these pull every probably 500 feet or so. We don't use these in electric fences. They go a long distance without having to have these on them. Wooden post, probably 6 inches. 5 to 6 inches is what you need for your corner post. Interior post, we usually allow 3 to 4 inch posts for our interior post. But for the corner post, where we have, for example, 6-wire fence, you need 1,500 pounds. You need a minimum of 5 inch post to to absorb that pull. Fiberglass posts work well for interior posts, but not for corner posts. There's a bunch of fiberglass posts on the market. There's also some flat T-posts that are fiberglass that work pretty well too, where the fencing goes right through them. There's the composite post, which works too. Nice thing is you don't need an insulator for a composite post. These should be driven right in the ground. I would put a wood post about every 3 of these, just because if you get heavy snow or conditions like that, or these compost posts bend over, and even cold weather, they can break sometimes. The same thing about the fiberglass post. So I would try to include a wood post every 2 or 3, probably every 3 of these composite or fiberglass posts. The wires are attached with these cotter pins. They work really well on these posts. And then on the fiberglass T-posts, they actually go right through the hole in the T-post, and they're strung through. And that works pretty well. Make sure they're loose so they can be tightened or loosened. You don't want them tightened. You don't want the cotter pin around the wire very, very tight. Nice thing about these is they are very flexible for deer or wildlife. They bend over, and they don't break usually. There's all kinds of stuff for temporary wires. You got step-in posts that work well. These are very easy to put up with a poly wire. Yeah, you got specialty fences for different. The best fences we have here for coyotes are probably woven wire fences, but we also have deer fences. We have fences for small critters, for gardening, things like that. But for the most part, if we're going to be grazing sheep and we have a real predator problem, we usually recommend woven wire with an offset wire in the middle for electric fence that can be subdivided. Jumpers are important, so you need to get a wire between the wires in order to connect and make at least, you need, for 3 or 4 wire fence, you want at least 2 that are hot. So you use these jumper wires to bring and you want to use the galvanized 12 gauge, same thing, same wire you would use on the fence. And that's about it for as far as presentation. There are standards and specifications in the Electronic Field Office Technical Guide. I'm not going to go through them all because what we use in Wisconsin is a little different than what we use in Illinois. But if we were to go through all those, it's just another 2-hour presentation. So I'm just going to say, go on to the Field Office Technical Guide, look at Chapter 4, and look at the standards and specifications for the kind of fence you're going to be building. And that should do it for today for our presentation.